Hey everybody, welcome back to another year of chemistry at Denham Springs High School with Mr. Simmons. As you can see, I got the Millennium Falcon shirt on today, so we're ready to roll. We're going to do scientific notation, calculating with scientific notation. If we have addition and subtraction, there's one set of rules to follow. If you have multiplication and division, there is another set of rules to follow. First, we're going to start with the addition and subtraction rules. The first thing you have to do is get these powers of 10 the same, because if you didn't, these would hold different place values, because as of right now 2 times 10 to the third represents 2,000. 5 times 10 to the fifth represents 500,000. Much bigger number on the 500,000 side, and this would not match up with the 5, so you can't just say 5 plus 2, and you will be able to, but we got to get it in the right place first. Let me show you what I'm talking about. Okay, first thing we want to do is, if you can put this in your calculator and get it right every time, by all means go for it. If you are proficient at doing scientific notation in your calculator, you will be able to use a calculator in this class every single day and on the test, so by all means do that. If you are not proficient with a calculator with scientific notation, all it takes is one parentheses in the exponent, one parentheses over here to mess things up, and your answer will be way off. So here's what I always want you to do in this class if you're not proficient with a calculator, is get your powers of 10 the same. And it's easier for students, I've found in the past, to go from a bigger number to the smaller number than go from the smaller number to the bigger number, because if you went from 10 to the third to 10 to the fifth, you would have to move the decimal backwards. If you go from 10 to the fifth to 10 to the third, you'll be able to move your decimal forward, and you'll be dealing with whole numbers rather than bringing decimals into it. So let's do that. Let's go 2 times 10 to the third plus, and then we want to get this times 10 to the third. What would 10 to the third, taking away 2 powers of 10, what would that do to this number? You would add 2 powers of 10 by jumping 2 decimal places, because in essence it's times 100. 2 powers of 10 is 10 times 10. 10 times 10 is 100. And you'd multiply it to that. So we end up with 500. So 2 plus 500 is 502. And then you keep, when you add and subtract, you keep the exponents the same. It's just like if you were doing centimeters or something. You could think of these as units, because if you had 2 centimeters plus 5 centimeters, you end up with 7 centimeters. You just add the numbers, you don't add the units together. The units are just the common ground. So centimeters plus centimeters is centimeters. You'll see in just a second when we get into division and multiplication that you will multiply these together, and that's when we do something different with the exponents. So for right now, you end up with 502 times 10 to the third, which is essentially 502,000. But we want to work our answer back into scientific notation. So we end up with 5.02 times 10 to the fifth. Because remember, when you move this understood decimal from right here back 2 spots to 5.02, you have to add those 2 spots back into your exponent. And remember, proper scientific notation is putting the decimal to the right of the first significant figure. All right, let's try a different one. We'll jump into the other rule of multiplication and division. What if I had 7 times 10 to the 8th times 9 times 10 to the 6th? All right, in this case, with multiplication and division, you're going to multiply the numbers together, the real numbers, the 7 and 9, and then the exponents. Remember, when you multiply exponents, you add them together. When you divide exponents, you subtract from one another. So let's do this one. Let's go 7 times 9, and this is what I do. I've told you in class before. If you're proficient at putting this in your calculator, go for it, do it. If you make one little mistake, though, it can throw your answer off. So normally what I'll do is I will pull the whole numbers out of the problem, and then I'll pull my powers of 10 out of the problem, and I'll work them separately. 7 times 9, and then over here you have times 10 to the, what is 10 to the 8 plus 10 to the 6? I'm sorry, times 10 to the 6. You add them together, 8 plus 6 is 14. So you get 7 times 9 times 10 to the 14th. This is 63 times 10 to the 14th. Then, to put it back in proper scientific notation, we take this understood decimal, move it back one spot to 6.3, because we always want that decimal one space to the right of the first sig fig, times 10 to the 15th, because you just took a spot back. That is a value in the 10 place. So it goes 10 to the 14th, put that 10 back in, 10 to the 15th. 6.3 times 10 to the 15th. I'll work one more for you, a division problem, so you can see how we subtract out the exponents. All right, let's look at one. 4 times 10 to the 5th divided by 8 times 10 to the 2nd. Okay, in this problem, you're going to work the division and the division of the whole numbers and the powers of 10 separately again. So I'll pull these out separately, and I say 4 divided by 8, and over here I have 10 to the 5th minus 10, or 10 to the 5th divided by 10 to the 2nd, which is essentially 5 minus 2, and that's 3, so 10 to the 3rd. So I'll have 4, whatever the value of 4 divided by 8 times 10 to the 3rd, and 4 divided by 8 is 0.5 times 10 to the 3rd. And if I wanted to put this in the proper scientific notation, I'm going to move this decimal over one space to the right to get it into scientific notation. So that would be 5 times 10 to the 2nd. And notice my value went down because I came from the left. If you come from the right, you're taking away a power of 10. If you come from the left, you're actually coming from the less than 1 side, the decimal side, and when you come from the left, it takes away a power of 10. Coming from the right, you add a power of 10 when you move your decimal. So 5 times 10 to the 2nd would be your final answer in this problem. And in some of these problems, I haven't gone back and shown you exactly how to put it into proper sig figs. I'm just trying to get you through this right now, and then we'll concentrate on the sig figs after this. All right.